Very small. Okay, 9 o'clock and all's well. You've all seen the note well before. What you see, what you hear when you leave will go in the corporate record and will be used against you. Okay. Let's do some agenda bashing. What we have today in the meeting now and this evening, we have a number of different drafts. This morning, what we've really got, I would suggest, are two major discussions with some parts in each. To begin with, we're looking at this question of addressing. What in the world is bouncing on my laptop? Okay. Looking at the question of how many addresses should we give to a host? Should a host have one? Should it have a /64? Should it have a /8? I don't know. How many addresses should we give to a host? Part of that is actually a draft that's under discussion in NV03, which is looking at some technology that Facebook is experimenting with. Lorenzo, we want to finish up the address availability question, and John Brzezowski has some comments from Comcast. And then we've got two drafts from Fernando Gaunt looking at extension headers. Most of these drafts, so the host address availability, I'd really like to complete today. We've got two outstanding comments, and we want to bring them to closure. With Fernando's, that'll be a more freewheeling discussion. We've got basically a report on his experimentation with Google and others, and then some further comments on so what. And then this afternoon, we've got the design choices document, which if we can bring it to closure today, fine. If not, we need to know how to bring it to closure. We've got the update to RFC 6145, which I'd like to think we can bring to closure today. And then Dave Plonka offered to make a presentation about how we, the internet, use IPv6 address space as seen by Akamai. And so that's actually a talk he gave last week at IMC, and he offered to do that here. I thought it might be relevant. And ultimately, we have a question about, so we have some other drafts that have been hanging around, and what do we as a working group want to do with them? So now, agenda bashing. Does anybody want to change the agenda in any way? Hearing none. Okay, that's the agenda. Hello. Okay, Tom, are you around? And this is for you.
Good morning. My name is Tom Herbert. I'm going to talk about, as Fred said, some of the work that we're doing kind of at Facebook around network virtualization and basically leveraging IPv6 addressing. So before I go into ILA, I'd like to give a little bit of background on why IPv6 is important in the data center. This is actually kind of prerequisite for ILA. So the best answer, of course, is this is to scale the number of hosts that we basically bring up in the data center. So it turns out that most data centers, obviously, we use a 10/8 for internal addressing. That's a lot of hosts, and most data centers will never have near that number. So the basic problem, though, becomes in the hierarchical address assignment, and quite frankly, renumbering time and time again gets to be old, and at some point, it seems better to switch to IPv6. But from my point of view, there's actually a lot of forward-looking benefits to IPv6 in the data center. So the capability to address much more than just physical host, which we'll talk a little bit about with ILA, is an important one. The flow label for ECMP, this is actually very compelling because this allows us basically to get ECMP for non-UDP, non-TCP traffic. And that will allow us to deploy other protocols in TCP and UDP. And then we would like to look at extension headers. The big if here is whether or not extension headers have reasonable support in hardware. So Facebook actually has pretty much a deployed IPv6 data center. The process was not terribly difficult. We leveraged the fact that most services live behind a library, so the IP addresses were transparent to the application, which is really nice. As expected, we did encounter various issues. Some applications hard code addresses of 32-bit integers. Java, I think, is pretty much known to be difficult with IPv6. We did a lot of work in the performance side, especially in the Linux routing. Has a lot of rework. And then hardware side, some rack switches had interoperability problems, particularly with neighbor discovery. And we're still trying to figure out all the performance issues. So one effect of IPv6, even though it's been around a long time, a lot of vendors still are a little bit behind in kind of hardware support. So we're working with them to bring that up. So that's kind of the background for V6 in the data center. Now, motivations for ILA. This really has to do with kind of virtualization and virtualizing the data center. One of the simplest things is we just want to have an address per each task. So you can imagine a data center, we're running some number of tasks, each of them its own set of binaries or programs. If we can address each of these tasks with an IPv6 address, that actually solves a scheduling problem in terms of port space. So for instance, if you want to bring up 2 instances of the same task on the same host, right now we would have to give them a different port number. And this becomes quite a scheduling issue. Port numbers really don't fit into DNS. But if we go with an IPv6 address per task, that means we can actually do the lookup per task instance based on IPv6 address, then use a single port for all of the instances. The other critical rationale is network virtualization. And this actually breaks down into different types of network virtualization that we might want to do. The one that we're first interested in Facebook is the so-called container network virtualization. And this is the idea kind of similar to the task where tasks run in containers, have their own resource isolation. We can migrate these containers around as needed to help the job scheduling, but there's no VM involved. And with ILA, one of the big goals here is if there's no encapsulation, we're basically sending packets on the wire, plain TCP packets, for instance, then there's hopefully no performance loss, no need for special hardware. As I mentioned, the alternative, this can also be thought of as an alternative to the network encapsulations, particularly some of those in NV03, where, for instance, we might do NVGRE or VXLAN or GU. And the idea is you put an IP packet within an IP packet and send it. ILA can get us out of that, which has a lot of efficiencies. So we're not adding extra overhead to packets. We're just modifying the IP addresses. This is transparent to the hardware. There's a lot of potential benefits of that. So the solution of ILA is to split an IPv6 address into identifier and locator. This does look a lot like ILNP. But in ILA, we really don't define the control plane as much as it is in ILNP. The concept of the container virtualization, each task will have its own unique virtual identifier. And in order to...
Question for you.
Yes.
task? Is that a process or is that a set of processes?
It can be thought of as, I think specifically in this case, let's think of it as a process. So a unique identifiable entity in the network. So if I'm contacting a task, it has to be the equivalent of a virtual host, or it is one unique entity. So each task will get its own identifier. And what we need to do in order to deliver a packet to its destination is map the identifier to locator. So this is kind of like doing an address lookup on somebody's name. It's actually very similar to ARP and some of the lower level mechanisms for physical to or virtual to physical address mapping. So if a task migrates between hosts, the idea is that the identifier is fixed for that task, the locator changes, and any communicating peers will continue to use the same address, and the mapping service actually directs packets to the new destination. So from that, we should get some semblance of mobility. One of the important characteristics, though, is since we intend this to be really data center scale, and this is not just for a few VMs coming in, but we really want all of our tasks to have this mobility component, performance is critical. And so in ILA, we really are shooting for near zero impact when not migrating. So the address split, like I said, very similar to ILNP. The upper 64 bits would be the locator. This is routable in the sense that we can route over the network to basically a translator. In NV03 parlance, that would actually be a NVE. The locator itself that identifies the physical address is not used as the connection endpoint. We have a separate prefix that would be common amongst all of the identifiers, kind of the externally visible prefix. That's what would go in a DNS. So it'd be the combination of this externally visible prefix, the identifier. That's what the application would see. Application would send that, and that would turn into a mapped locator and identifier. One other thing is we did add some bits into the identifier so we can have typed identifiers. This allows, for instance, a way to embed, say, an IPv4 virtual address in a virtual network identifier into an IPv6 address. So one thing I should mention about ILA versus some of the NV03 proposals, the one downside of this is we really don't have the extensibility. So for instance, if security is an issue, there's really not a good place in the IPv6 packet to put security. I know that there's been some proposals, maybe use flow label for that sort of information or possibly extension headers, but right now it doesn't seem to be a great fit. So we're assuming that this sort of traffic, the security is handled at a lower layer through other mechanisms. Some of the advantages of using ILA for network virtualization, it's very easy for a VM, for instance, to talk to the external world. They don't need to go through a true NAT. They just go through an ILA translation. And also, we can have two VMs and two completely different virtual network identifiers as long as they live in kind of a shared address space. We can use ILA to actually allow them to communicate per some policy. It's one of the things that kind of really isn't so easy in encapsulation. So in terms of details, as I mentioned, we need some sort of system or service to map identifiers to locators. And as far as I can tell, this is nearly identical problem of mapping virtual addresses to physical addresses. So we expect to be leveraging kind of the same control plane that in NV03 or whatever other control planes are out there. As I mentioned, the user visible representation of the ILA address, this is something that needs to go into DNS. And this is actually what is in the TCP endpoints, for instance. And generating the identifier per task, it's actually a pretty non-trivial problem in a large scale data center. Our current thought is to use some sort of time stamping, unique identifier, something like that. So as I mentioned, the architecture follows a lot of NV03. So we're leveraging that. Like I said, the pre-translated packets are routable on the network or can be translated on the host. One of the things that we probably will implement is some sort of ILA redirect. So the idea is if a router or host gets a packet and it knows the destination is someone other than itself, it can send back something like an ICMP redirect, but probably over UDP back to the transmitter. Question?
Dave Taylor. I had a question on a previous slide. You don't have to go back, but I was looking to see if it was in the deck, and I couldn't find the answer. The VNID, can you elaborate on that? Because you're saying it's part of the identifier, not part of the locator. So then I assume that the VNID is just a way of grouping identification and does not correlate to location in any sense?
The virtual network identifier is basically, think of it as identifying a tenant in a network. And within the tenant's address space, they can use their own addresses. What we would expect in most multi-tenant environments, pretty much all the customers are going to be using their own 10/8. So they'll obviously have conflicting addresses. The virtual networking identifier, both here and in NV03 encapsulation, actually differentiates between the two different address spaces, if nothing else.
Right. I was just trying to make sure that it was actually a hierarchy of identity and not part of any notion of location. Because
it has
would
nothing to do with
port.
location.
Okay.
It's
I
meta
think
location.
the acronym is a little bit misleading then, because it's not a network ID, right? The network
it
ID is like the bottom end
yeah,
of the
I
locator
know.
part,
It's kind of confusing because the term ID is so overloaded.
So I just wanted to clarify to make sure it was defined within the context of this group, which might not be familiar.
The problem is we have identifiers in ILA context. I mean, virtual networking identifiers here. They both use the word identifier.
But your answer is it's not
context.
identifying a virtual network. It's identifying a tenant, because a network might be correlate to network topology, and that's what the locator is for. Virtual network topology, right? Routing decisions.
So translations, I think we mostly have settled kind of how it would work. So for unicast, it seems like we only want to translate the destination address, leave the source address to the untranslated address. As pointed out on the list for multicast, we will have to translate the source address if we expect multicast routing to actually work. So here's an example of the flow. So as I mentioned, packets start from the source, and in this case, we're sending to triple or quadruple 3.1, get that out of DNS. And the way this starts is a source may have no real locator mappings. So it sends to a kind of a default, which is this ILA router in the network. These would have a way to get all of the mappings. So they can actually forward the packet to its final destination after translating. And so that would be number 2. And then in number 3, they would send back the ILA redirect. Subsequent to that, the source would have the information for that destination and then can send the packets directly. And that's how we can eliminate the triangular routing from the beginning. So the status, we posted the version 0.1 of the draft that was on the V6 ops list. We do have an upstream implementation in Linux, and internally we are just commencing some pretty deeper testing, bringing up some canaries. The address per task assignment actually is something that is still kind of being designed. This has to integrate with job scheduling. And then the design and the implementation of the ILA router, as I mentioned. Right now, I think the current belief is this it's fairly not a high load system if we get the redirects right. So we should be able to build this either from a user space application or leverage some of the kernel routing kind of things. Okay, any questions?
Hi, Mark Townsley. You mentioned that you may be putting the ILA addresses, the per task ones, into DNS.
Yes.
Is that for your internal operations for VM to VM communication within the data center, or are you exposing that out to the user so that the users would see a greater number of V6 endpoints for?
You mean the internet?
Yeah, Facebook user, yeah, the internet.
There are modes where we believe that users can use this stuff via those addresses.
Okay.
The one interesting area that we really haven't explored is how this would interoperate with something like Anycast, and whether we could use something like this to solve some of the Anycast problems. So the short answer is, as far as any user or application is concerned, the addresses they're getting out of DNS, it doesn't matter. It's transparent whether or not they're being mapped. And in fact, it's even transparent whether they're talking to a mobile task, a physical host, whatever. I mean, this is the power of kind of the addressing scheme, is that it's all transparent to the end user. And that's critical. We can't change applications, obviously, for this. And in fact, there was one very interesting case where we wanted VMs with IPv6 addresses to talk to a common service in a data center. And the problem there is we can't give all these VMs in different tenants their own IPv6 address space. So all these VMs will be coming into our poor TCP application with 10.0.0.1. How do we fix this? We can't run an instance of the application or the service in each virtual network. So one thing they can do to solve this is actually translate those IPv4 addresses into IPv6, have the service run IPv6, and then the service sees IPv6, but the end user sees IPv4. So you can actually do a mixed match in order to provide kind of that common capability.
Okay, thanks.
I have one more question over here in the far corner. If you're expecting, it sounds like you're expecting fairly dynamic updates to the DNS to keep track of who's got what, where, and when. Is that kind of correct?
Yes, I think if the assumption is that all this goes into DNS, the locator information does not go into DNS. The only thing in DNS is just a name and an address. And that address has meaning all over the network, but it is, if it's an ILA, if it's intended to be translated in ILA, it's essentially location independent address.
So where do you place your DNS servers so that they're reachable?
So I'm not sure I quite understand the question. So there's actually two service lookups we have here. So DNS just works as it is. The new service lookup is the mapping of identifier to locator. Is that more of what you're referring to?
I don't believe the DNS service itself is mobile and is not migrate around. And therefore, when you have a bunch of these virtualized networks, the routing has to work to reach the DNS server unless you place a DNS server instance inside that virtual network that you're defining.
Or if that DNS instance is reachable from all of the virtual networks that you've defined.
If you're making the presumption that that is the case,
then you need to do the mapping.
Then you need to do the mapping properly, and you need to ensure that your routing is working to make sure that that golden DNS address is always reachable.
So I will agree with that for bootstrapping some of these services, not everything needs to be or should be migratable. In which case, say DNS, if it has that property, yes, we would not want that to be migratable. So in other words, there will be core services that don't need to be migratable.
Can't be migratable.
Right, but our stock tasks, for instance, if I was doing some sort of storage server, I could make that migratable. And by the way, the fact that we're doing ILA does not mean that it's migratable. It means that it's location independent. So once the task starts, it does not have to migrate. And in fact, we don't think many tasks will migrate on average. Most of them will run to completion without ever moving. Some of them will be pinned. We should have that flexibility kind of built in.
Thank you.
Brian Haberman, Fred, can you go back to the slide with the diagram on it?
That one? Oh.
So speaking as one of the int ADs, this looks a lot like mobile IPv6. Have you really considered whether or not that would apply here? Because essentially what you have is a home address and a care of address that are your identifier and locator, and there are protocols that already do this for you.
Are these protocols encapsulation or modifying the addresses?
There's an extension header that has the home address in it, and it simply just changes it out when you do the route optimization of mobile IP.
So as I mentioned in the reasons for IPv6, one of the things we would like to use are extension headers. However, we still don't use those in the data center. They're not used at Facebook because of hardware incompatibility. So any solution that requires extension headers would require hardware support of some of our offloads.
It's a destination option.
It doesn't matter. For instance, last week we found out that most NICs will break checksum offload when extension headers are present. And we can't do that. So it's an interesting idea, and I know there's various other alternatives. I know that there was a proposal to put this sort of stuff in the flow label, use extension headers. But the other side of this equation is we need something that's compatible with what we have deployed today and doesn't require us to swap out a whole bunch of hardware. And you could argue this is just a type of glorified NAT. It's stateless NAT, so it's hopefully not the horrendous stateful NAT.
So my fear is that all of the various security optimizations that had to be put in for mobile IP, you're going to have to recreate for this model. And so I would highly recommend that you talk to your vendors to see if mobile IP is something that could be applied here, because that gives you solutions for those problems.
Well, we are certainly hounding the vendors. I need IP extension headers for other reasons, but right now, unfortunately, they're not an option.
Don't go away, Brian. I think half of my question is for you. Dave Thaler. So a lot of the security issues I think Brian is talking about is actually things that would apply to the dashed line. The dashed line up there is the redirect, it's not the data packet. Is the dashed line doable in mobile IP without extension headers? I don't remember. No. I'm hearing yes and no from the audience, so I don't know. But so I guess the question for the presenter is, okay, even if you don't use extension headers for the other one, is whatever mobile IP messages is used for the redirect, is that messages that are reusable, in which case it's just a mobile IP extension as to how do you actually encode the data traffic when dealing with that. But if the redirect message, because I think a lot of the mobile IP solutions for how you deal with preventing spoofing and so on is really how you authenticate the redirect, because that's what actually creates state in the source that causes it to do different things, right?
Yeah, I mean, by all means, since that's not the data path, I think we would try to leverage whatever exists.
Eric Klein, to respond to Dave and to Brian. I think part of the idea here is that the control plane that you have to use on the wide open internet is not, you don't have to be restricted to that control plane when you're in the data center, right? And you can integrate the control plane for these redirects with your job scheduling stuff as things move, which also updates DNS and a bunch of other things.
Okay, so if you have any more comments, you can talk to me offline. That's no problem.
Great, thank you. So Lorenzo? So you didn't actually give me slides.
I sent slides. I knew that at least one person except me received them, so I might have typoed. I sent them to V6OPS-chairs, didn't I? David, can you check this with the email I sent? I sent them to my co-authors. But they were in.
Sent them last night at 1 a.m. Okay.
Yeah. I thought today was a flexible term.
No, actually, I asked for them Saturday and sent you an email saying, yes,
oh, you did?
I need these slides today.
Yeah, yesterday.
1 a.m. this morning? Not yesterday.
No, yeah. Sorry.
Anyway,
This is your local time zone, right?
Yeah. So yeah, that's true. Okay. So yeah. Thanks. I have to stand in the box. Okay. And I can also look backwards at my slides because I can't see them. Anyway, so this is just really a brief update on the status of the draft. My co-authors, most of them are here, not all of them. So what's the current state of this draft? We, the working group last call time.
Do the blue sheets need to go anywhere? Has everybody seen the blue sheets?
Blue sheets over there.
Okay.
A working group call for comments expired on September 28th. There still seemed to be relatively broad support for the basic messaging. We made some minor changes. We uploaded 02 at some hour during the night when the tracker opened again for submission. So what changed? So we got a lot of support and a lot of suggestions. We tried to make a lot of clarification suggestions. We tried to integrate those. There were some concerns. They didn't seem to be sort of widely spread, and there were a few concerns from individual members, and we sort of, the ones that we found to be the most relevant were here. There was a point about a 64 per host being excessive, and we think we addressed that by stating that you basically can't subdivide a 64 more than, you can't subdivide it because it essentially there's no guarantee to work for a 7421. And also, the draft only recommends 64 if you can't use a stateless addressing mechanism, and if you're a general purpose host. So if you're in a data center, not a general purpose host. If you're on a network that provides Slack, like most residential or mobile networks, this is irrelevant because you already have a means of obtaining addresses. There was one concern that the motivations were weak and that the recommendations was one size fits all. Well, the authors don't believe the motivations are weak. Obviously, that's sort of a matter of opinion. But we do feel that we provide lots of justification. And the recommendation, we believe that having a one-size-fits-all recommendation is appropriate because it is something that applies only to general-purpose hosts. So if you're a general-purpose host and you run general-purpose software, then there is a set of operations that users expect to be able to do, and therefore it's appropriate to make those recommendations. And as a reminder, the argument is not we need more address space. The argument has always been we need more address space if we don't want to use NAT. Okay, so in that, remember, that's always the context here. There was also a comment that we should provide more clarification that the problem is really that people want to charge more for more IP addresses. I think that's not the only problem. And we do say in the draft that, there's nothing we can do about it, but we do say in the draft that it's not very useful to do this. There was one last comment was you need to state why it's not feasible to acquire an address when you need an extra address. And again, the authors thought that that was actually quite substantially addressed in the draft. We made some minor changes. We added lots of clarifications. We added some text to further justify the recommendation of 64 in the case where you do have to use stateful addressing. And there was a discussion, several people wanted us to say longer prefix instead of smaller prefix. We did that, and somebody said that they want to use something else. I don't know. Well, we can discuss that. There was a request to document the assertions that several university networks use Slack and tracking together, and we did that. Tim Choan helped. He put us in contact with several universities that do this. And yeah, we fixed the ID nits and made minor clarifications. And so not sure what to do here. If we're still happy with this text, maybe we can advance it to IETF last call. It's sort of up to the working group.
Okay, thanks. Stay up here a few minutes. So the comments that Lee and I have kind of been holding off on are Owen DeLong's concerns about the prefix length and Barbara Stark's does this have to be done in my network? Does this relate to primarily data center, or is this also residential residential broadband? You care to comment on that?
Well, those were the ones that we list here. Is there a pointer here? No, there isn't. So Owen's comment was the first one. So is a 64 per host excessive? And I think the issue there is that you can't actually. So in 7421, it says that you can't actually subdivide a 64 because it's not guaranteed to work. So that's one issue, and it's true, and it's true that in a data center where you control sort of the applications and you control the hosts, you can use something that's not 64 because you can guarantee that it works and you have more control over the whole ecosystem. But for a general purpose host, it's not known if it's going to work, and also the applications might not support that. So Owen didn't seem to belabor that point after we sort of responded to it. I don't know if he's in the room. Is Owen here? Yeah, I don't know what to do about that one. And the Barbara's concerns were that the use cases are weak, and the recommendation is one size fits all. That's the second point there. That's sort of mostly up to what we as a working group think. I mean, the authors feel that this is in fact justified, and we do have a lot of justification, but it sort of depends on what the working group thinks, right? So I don't know if there's rough consensus that this is reasonable, then we can go with this. If not, I don't.
Suresh?
Yeah, Suresh Krishnan. So like regarding the first point, I don't think it's excessive. And we had this discussion like Yeah, it didn't like me. Suresh Krishnan again. So I don't think the 64 per host is excessive. And we had this discussion like 15 years ago when we did V6 for 3GPP hosts. Okay?
That's true.
So if you look at like RFC 3314, there's actually text you can probably use as is. Like
that's a good point.
It's like a very philosophical grains of sand in the world kind of thing, but you can actually use some text from there.
Yeah, that's a good point. Thanks. Yeah, we'll look at that.
Fred Templin from Boeing. I think I said this on the list, but I'd like to see that this draft discusses DAD implications of configuring lots and lots of addresses. When you need to do DAD, when you can omit DAD.
What implications do you have in mind? I mean, the protocol supports multiple addresses if you want to do DAD.
Right. If you get your addresses by SLAC, though, you have to do DAD over the interface over which you got the addresses.
Yeah.
If you get the addresses by DHCP-v6 prefix delegation, you may not have to do DAD because that prefix has been delegated for that node's exclusive use.
Yes.
Okay. I'd like to see the draft discuss some of that.
Do you just want a sentence that says this? We can put a sentence that says this. I mean, I don't. Are there any sort of other like technical implications you'd like to sort of see us address, or do you just want to put a note to that effect? We can do that.
I'll go back and have a more detailed look, but having a note would be a good start.
Okay. Send text if you can too, if you want.
John Brzezowski. So I was thinking about something that you and I talked about, and then we exchanged emails about. I think in our residential model, we don't kind of have any. We had to turn everything on, right? Slack, stateless DHCP, stable DHCP. We're getting ready to turn on sub-prefix delegation, et cetera. I mean, I sent you a few comments off list. I'm not generally opposed to this because I'll be in the queue for the next topic that's not too different than this one. I just don't want to be in a situation where I think this maybe where Barbara's come from, where if we have a comparable implementation in our homes today, that we're now forced to do something like this. I mean, I think it's important to make sure that we have we compare and contrast what's available today and say, hey, by the way, if you have a strict addressing model in your residential kind of implementations, then you should consider one or the other n number of alternatives, right? This possibly being one of them, right? Because for us, we didn't have the choice, the luxury of just picking one, right? Because back in the day, some did DHCP, some did Slack. I think that's really the only concern that I have. In general, I'm not opposed to the work.
I mean, the draft is intended to be agnostic towards deployment models. All it says is as long as you provide the ability for a host to obtain more than one address by any means that you have, any means that it supports, that's fine. So if you do Slack, sure, that's fine. Yeah. If you have a 64 per host because you're running on a cell network, that's fine. If you require that the host show up and say, give me an address space, which is today, which means if you run DHCP-v6 stateful only, then the recommendation in that, then we do make a recommendation in that case, which do use PD, don't use NA. But that's the only case in which it makes a recommendation. Everything else, the only recommendation that it makes is like, don't just give a limited number. And so, yeah, Slack is fine. And on a 64, I get a 64 for my cell provider. I can create as many addresses as I want, and that's fine.
Right. So outside of, so on my corporate desk network today, right, we do Slack. So it sounds like I'm okay there based on this.
That's fine. Yeah. I mean,
now,
yeah.
at some point in the future, we might turn on DHCP, and at that point, we would do Slack and stateless TCP and stateless TCP. Again, I still think I'm okay based on what you're describing.
Well, yeah, because the draft says if the network requires the use of explicit addressing to obtain an address. If you use Slack, then you don't require the use of explicit requests because you can form an address if you want. This is kind of like what we're trying to avoid is networks that, you know, basically enforce the host asks for address space and then only provide like, you know, 1 or 2 addresses. And that will, and what we think that'll lead to basically hosts implementing NAT66, which we think is a bad idea. That's kind of,
that's a terrible idea.
But as long as you implement Slack, this is fine. And if you don't want Slack for security reasons, then we say, well, do DHCPD instead.
Stephen Bott, some question, because I haven't seen it being addressed in the draft. What do you think about the renumbering implications if there's a use of DHCP6 or DHCP6 PD instead of using Slack? I mean, usually in the host space, you see that with Slack you can get immediate renumbering. But with DHCP6 or DHCP6 PD, nobody really implements the reconfigure feature.
I thought they were supposed to must implement it, as you say.
No. It's only supposed to must on CPE routers, yeah.
Well, so I don't. Well, we tried to steer clear over making statements like use this or use that, and we would like to continue to steer clear of those debates.
No. I mean, maybe the point is maybe you should think about if that gets consensus, if you make a statement that hosts should be able to renumber, at least make it a should.
And so that would be essentially a function of, but that's effectively a function of the host's ability, whereas what we're trying to do here is make recommendations to networks.
Well, I mean, it requires interaction on both sides, right?
Sure, but okay. Mark?
You just said you're trying to avoid implementing NAT66 on the host. So
yes.
your heart's in the right place here. You want to avoid NAT on the host by telling the network to do something. But when he says, oh, the network might do this, so please be resilient to that, Mr. Host, you're pushing back. That's not fair.
I'm not pushing back. I'm saying what we currently recommend is only a network side recommendation. You know, if we want to make a host side recommendation, sure, we can do that. I mean, we have to figure out if we have consensus for that, and we can, you know, it doesn't have to be in this document either.
Mark, I think
pushing back more. Yeah.
Eric.
Okay. Yeah.
I think also, you know, the comment was about renumbering under DHCP. It's like, well, the DHCP server, when it gives you the prefix, it gives you a lease. Are you then saying, oh, by the way, I lied when I gave you the lease time and I'm going to renumber anyway, and you expect the host to modify that? If you want to renumber it, use shorter leases? What did you have in mind?
No, I'm saying don't do that, because I've seen that being done by ISPs. They give you a router and they offer PD support, and what they give you is 60 seconds lifetime prefixes, and then you have a constant churn of renumbering. And what I'm saying is, if you do PD or so, then please make it a should requirement for the network side to at least support fast renumbering if the client also supports it. So you don't run into these issues that the ISP gives you CPE router, and if you request a prefix from it, you get address lifetimes of 60 seconds or 30 seconds or so, which is like awkward.
Okay, so but the network is only going to do that. So the network can do that, and we can put a recommendation saying if you choose to use DHCPD, and then we're going to have to qualify that. We're going to have to say, well, if you're a network that might renumber, because if they, you know, somebody might say, I'm a data center, I'm never going to renumber ever, right? And so you have to word that carefully. Okay, so you say, well, you know, if your network might renumber, then we recommend that you support DHCP-PD on, we support reconfigure on the server side, yeah? And then what do we say about host? Because none of them actually support renumber or reconfigure, or they're not supposed to, they're not required to, right? So we can say, please support this, but there's no guarantee that it's going to work.
Right, but at least unless there is network side support, hosts won't ever implement it. So the thing is, I mean, I agree with you. There are network or data center cases where this is not applicable, but especially for home cases, I think it sometimes at least is. So if you use a stateful mechanism, at least make it a should requirement that if the host supports it, the network also supports fast renumbering. Is that kind of acceptable to you?
I mean, it seems like a fine statement to make. I don't know if it's in scope for this document.
Okay.
Maybe we should.
So let me start with I support the draft. Let me maybe take Lorenzo's side in this. I'm not sure whether or not a recommendation ought to be made, but it seems like it would be fair to add a clarifying sentence that at the time the draft is written, not all hosts that do support this DHCP capability necessarily support the reconfiguration, and that may be an implication on what mechanisms a network operator would choose to use. And that doesn't say anything about what hosts ought to do, but it observes that there is, at the date the draft was written, there is this operational consideration that network operators might want to think about.
So you're basically saying we should discourage DHCP-6PD because it doesn't do renumbering?
No, Lorenzo, I'm not. All I'm saying is you keep there are multiple observations from the room that hosts don't support the capability today. It is a useful data point to put in the document that today, meaning the day, as of the day the draft was written, many hosts that support this don't support the full capability, and that network operators might want to include this in their decision of what mechanisms the network operator chooses to deploy.
Do you feel that that statement is in place and in scope in a document whose only assertion currently is, please don't assign a limited number of addresses? Do you feel that that's in scope? Because it's not clear to me that it is. You could say, well, we're completely agnostic to the number of to the mechanism you choose to use. If you want to use carrier pigeons, you can use that. You know, you have carrier pigeons with the addresses tattooed on their backs. You can use that, right? So I'm not saying. I'm just saying, is this something that we need to put in this document? I don't disagree with you.
I think that the informational sentence belongs in a document if the document even gets as far as this one already has gone, which is to enumerate a set of possible mechanisms that a network operator might use. Right? It's an informational sentence. Okay. It's not a recommendation, and I don't see that any harm could come from adding the short sentence.
Okay, that makes sense.
Bernie Volz. Ran, how many hosts today support PD? Hosts support PD.
No idea, but the audience seems to think not very many.
And I think that's the answer, is not very many. Lots?
Yeah.
Okay.
So
Windows
guys,
supports
when you come to the mic,
delegation
please state your name.
for addressing. Okay.
He stated his name. John Brzezowski. So one comment, one question. So for cable network, for cable modems, you know, CP routers and such, for example, I don't, you know, we see little to no value in being able to do multiple addresses. I don't think that's really your target anyway.
No,
right?
It's targeted to general purpose hosts, which a cable modem is not.
And then one other thing to Steven's comment, we do lower lease times. We leverage that successfully to facilitate renumbering. We've been doing it for many years with V4. We do it for V6. The intention is not to keep the lease times at, you know, 4 hours permanently. It happens on occasion where maybe that stays longer than it's supposed to, but we quickly fix it. But we do use that for renumbering daily. Data point, FYI. So thanks.
I mean, I'm just eager to avoid getting into an argument between you and him on a draft that's not actually on the topic. That's all.
So, Bill Manning, way over here. I'm sorry. Maybe should I stand over there instead? So how does this lovely host who sits here and is getting a variety of information off the network about acquiring new addresses or changing addresses or renumbering, how does he distinguish between an approved benign renumbering request and a hostile unapproved renumbering request?
If you don't have link layer security, you're toast is my option, is my interpretation.
So just looking at the incoming request, there's no way to distinguish whether this is good or bad. It's just a request and act on it.
I think so. I mean, if you don't have link layer security, you're dead in the water, basically, whatever you use.
Fred Templeton. So I may have missed what was just said, but it's perfectly fine for a host to use the DHCP-v6 prefix delegation. Even though it says requesting router, a host can act like a requesting router from DHCP standpoint, but then act like a host with the prefix that it gets back from DHCP.
Mm-hmm.
So I've got clients that do that today.
That seems like a fine thing to do. Yeah.
From my perspective, if I put an application on a router, it's acting as a host.
Michael Abrahamson. So I'm with Lorenzo here on trying to keep this document without a lot of implementation detail. I think we should solve that afterwards. If the principle here gains wider acceptance that this is the way it should be done, then we could look here into mechanisms and how to do renumbering and all those things, because I'm sure that there are a lot of things that hasn't been brought up here yet.
Is it worth taking a feel of the room and which way we want to go on this?
That's kind of what I've been thinking about. So just listening to the discussion in the last few minutes, it's clear that we don't have 100% consensus on this. And so we need to have some kind of a spin of the draft. But the question is kind of how much to do and what. So let me start out by asking, do the people present feel that the draft is within shouting distance of completion, or is it fundamentally flawed? If you believe that we're reasonably close, would you please hum? If you think the draft is fundamentally flawed, would you please hum? Okay, so I think that is the consensus you're looking for. Now, I have a problem with repeating last calls, last and last and last and last. I feel like I'm in an airport and hearing the 18th version of the last and final call for somebody to come to a gate. So consider this the 18th version of the last and final call. What I want to do is next week, I won't ask you to do it this week because we're all crazy. But next week, those that have come to the mic and commented and asked for changes in the draft, could you please post to the list? And I'll send an email today that you can respond to that thread. But post to the list suggested text, what it is that you would like to see changed and the argument for it. Then we can take it from there. Does that seem reasonable, Lorenzo?
Sure. I mean, I just hope we don't get into an argument where we just deadlock and we don't know what to do. But
yeah,
that's
well.
If we put a time limit on it, that's fine. All right.
Yeah. Okay.
Okay.
So thank you much. So John.
Hello, can you guys hear me? So I'll promise to try to take as little of your time as possible. So a little bit of background on where this work came from, and I do appreciate all of your comments on the mailing list. So in our continuing journey to enable V6, everywhere, basically, one of the places that has popped up most recently is V6 support for our community Wi-Fi. So I recognize that there may only be a few Comcast customers in the room, but basically This community Wi-Fi offering that we have is basically free to our customers. It's available in public venues and other locations. And basically, when you connect to it, it's called Xfinity Wi-Fi. Right now, it's all V4. We do leverage GRE tunnels to kind of as a transport for some of this. We kind of hand wave over that a little bit, but we do make mention of it because the intention is also to make that V6 only as well. But that's not really what the focus of the draft is. We make kind of passing reference to it. So our intention was to make it so that the UE has dual stack connectivity, right? So when you connect to Xfinity Wi-Fi today, you get that with a V4 address that happens to be NATed and no V6. We want to add globally routable IPv6 connectivity to it and effectively, do the right thing for the internet and also make sure that we don't have to add any sort of capacity to the NAT itself. So a lot of the work that you're seeing here came from that to make sure that we didn't blow up kind of the Wi-Fi service and ultimately the network. So we were concerned about making sure that neighbor discovery traffic and that sort of thing on this shared media really didn't start to just drag the entire quality of the service down in general. So what we did is basically we have the model where every individual UE is effectively allocated or using a dedicated /64. One of the reasons that we did that is we want to make sure things like Slack and privacy addresses and such continue to work as they, as God intended them to work. V4 is obviously part of this whole situation, but we didn't really want to waste time with that. And we wanted to really kind of make sure that as a part of enabling, Slack and these different addressing mechanisms, that we did not, break anything. We actually saw in the early stages of some of this testing that we did that if you turned on stateful DHCP6 and Slack at the same time, depending on how you configure your DHCP server, you could potentially hand out the same IP address that was generated by Slack if EUI64 was using. That did not work out well. So that, just to kind of give you some ideas of how some of these assertions came about. Today, there's no intention to use stateful DHCP6 for address assignment, but we are investigating the possibility for future work to do PD, which effectively is stateful. And in our RAs, we transmit 6106 in the RA for DNS servers. And the reason why we enable DHCP6 is because not every host in the universe supports DHCP. 6106, sorry. So we really wanted to make sure that we didn't leave any device stranded. We wanted every device to have an equal opportunity to have a V6 only experience. And again, the initial focus is hosts, not routers. So effectively what we've done is you have route advertisements, and when an RA goes back to an individual host, there's a unique 60 prefix in the PIO, along with some of the generic options. One of the things that we also do, and I won't bore you with the details, but we do everything that we can to make sure that we optimize kind of the plumbing aspects for V6. So neighbor discovery, since it's only a /64, there's really no risk of my host and Lorenzo's host trying to do neighbor discovery to one another because they're not addressed at the same prefix. So by virtue of doing that, we really kind of optimize the connection that the individual UE has, and we've seen some pretty favorable results. And there's a lot more details in the draft, like the LBIT we set the LBIT to 0, and we have a number of timers that we've already socialized with folks in the working group. So if anybody hasn't made any comments on that on the mailing list, please do, and we'll take a look at them. And again, our goal here is to make this, as more and more content and devices support V6, that this becomes a proper V6 only experience. So before I get into, let's say after this. Before I get to this last slide, where this comes from today is we are currently have this in trial. We'll probably roll this out systematically throughout between now and end of the year. So what you read now is pretty much going to happen. So, your feedback is still important and useful to us, so send it. But that is the current state of affairs. We'll look at making some updates in the future after we get some more experience. All right, come back and hopefully get a few more minutes, share those with you guys, and then if and when we decide to do things like PD, we'll keep you posted. And that's it.
So don't go away.
I'm not going to go away.
Michael Abrams, how do you define device? Is this the thing that has a Wi-Fi network interface card?
Yep.
So if it's bridging, you're taking everything that comes behind it as well as one device. Yep. That'll be in that /64, and it'll be in that GRE tunnel and so on.
So when you say bridging, you mean something like this?
Yes. If that is bridging, well, okay, that's a bit of a bad example. But if I have a Wi-Fi that connects a Wi-Fi router that can also act as a client, and it can bridge to a port, a physical port on it.
Every bridge device would get a unique 64.
So
let's use concrete examples. You take an airport, and you somehow bridge it. You connect upstream for Wi-Fi, and you also make it an AP for host to connect to.
Yes.
Right. It's not a router. It's not an RG mode. Right.
Yep.
Every AP, every UE, phone, tablet, Mac that connects to the airport would effectively get its own 64.
Okay, and if there are devices behind it, they will be in that.
That's the device I'm referring to. The Apple at the airport in that case is transparent.
So this GRE tunnel is per Wi-Fi attached.
The GRE tunnel is from the equipment that I own and manage, not Apple's.
It's per MAC address.
Yep.
Okay, I think this needs to be clarified anywhere what this device means, because I'm hearing two different things. Again.
So just to be clear, the AP that's actually broadcasting Xfinity Wi-Fi is my device. It is effectively in bridge mode, right?
Yes.
I think the question you're asking me is what happens if somebody else connects another bridge to my AP?
Yeah.
And I'm saying I will clarify this. I'll make note of this when I sit down. But the devices that connect to that secondary bridge, which is not my device, will be treated the same way.
Yes, and
we've yet to see it, to be honest with you, but
okay,
I'll make note of it.
Explain it to.
Yep, thank you. Yep, Fred.
Fred Templin. So this might be actually following on to what he was just saying, but I feel that there needs to be a lot more discussion about the use case and the details of the use case. For example, is it a completely unmodified UE that you would get at a consumer electronics store, or do you have to put something on there from the cable company? Is mobility and route optimization a matter for concern? How are the SSIDs deployed? What are the access points on a mobile might visit? All these details, I think, need to be described in more detail in the draft.
We could share them with you, but they're not open for discussion or change. They are what they are, right? So
I don't know what they are. So
okay, that's fine. We can do that. And the intention here is we, I'm going to guess if there's any Comcast people in the room, you're not going to be really jazzed if I force you to put software on your thing, right? So we made it so that is not a mandatory step. If somebody wants to go, if we want to develop some software, we actually do have an app. If somebody wants to go ahead and do it, great. But we can't assume that most people are going to want to do that. We talked about route optimization, on the mailing list. My personal opinion is I've got nothing further to say about that. We could talk about the SSIDs. We could talk about some other stuff that are new, right? But we talked about some of those subjects on the mailing list, and just for the record, I have no further comments about those.
So that
some of the items that you talked about here right now, route optimization being one of them, I said my piece on the mailing list. I have nothing further to add beyond what I've written on email.
Okay.
Right.
Are you gonna write up the details about the use case though?
Can I respond to that? Area director here. So I think what he's actually describing is kind of a case study rather than necessarily a piece of this draft. There's the actual mechanics of this, there's 30 APs in my building that say Xfinity Wi-Fi on them. So I kind of understand where some of that stuff comes from. And then there's another one out on the pole that also says that. And that's more like the kind of equipment you're talking about. That's actually sort of how we did it. And I think the mechanics of that probably don't belong in the draft because they're proprietary to Comcast implementation. But they are actually intended to be used by random devices that decide that they like Xfinity Wi-Fi because they have that at home and they pick it up elsewhere. So it is actually the CPE in this case is your laptop or your phone or your tablet or whatever.
Fresh out of the wrapping from Best Buy.
So if I get your point, Joel, you're suggesting that there might be a separate document of some kind?
Yeah, maybe, or even just a presentation on this is how we did it at Comcast, and here's where the slide deck is if you want to refer to that, and not have that in the draft, or maybe the draft points informatively at some website where this is described or presented at NANOG or whatever.
That's exactly what I was going to suggest. We could queue this up for discussion at a NANOG, and all those slides are public, and then we can actually make reference to it in the draft. Is that legit? Is that legal? I do that? Yeah. Okay. that good?
That's kind of like what I did with Arrow. I wrote up a use case for enterprise networks, and I've got that use case in a separate document.
I understand your request.
Okay.
Thank you.
Lorenzo Colletti, I think this is great because you can't. Hey, credit where credit's due.
And some oxygen.
I think this is great. I think, in fact, I think it should be turned. It shouldn't be a case study. It should be. Here's a model that you can use to provide V6 access on Wi-Fi. I would personally see it. I would personally love to see this as BCP. In fact, people may not agree with me, but I think we do have a problem for IPv6 on Wi-Fi because in V4 we have all these hacks that you basically do ARP snooping and force forwarding and all this stuff, and it kind of works. But in V6, it really doesn't play well with, for example, with Slack. It restricts you to a limited number of IP addresses, and you always have this crosstalk problem. You have to put in DAD proxies and neighbor discovery proxies and all this stuff, and it's just a lot of work. And if you can just spin up a 64 per UE or whatever, it's just so much easier. And in fact, I would love to see this be the way that we deploy V6 on Wi-Fi, on community Wi-Fi everywhere. You've got nice isolation properties and everything. We should just say that this is the way we do it.
I appreciate that. And if I'm not mistaken, I think, unless I was entirely sleep deprived, I think we did mark it as BCP.
Oh, you do? Okay.
Yeah, I think so. And then the actual real reason why I'm up here is because of you. And I think Igor also, if he's here, he expressed some interest in this work as well. Otherwise, I wouldn't even come here to share. We would have just done it.
But it's great. I mean, as we move to V6 on community Wi-Fi, we need to know how to do it. And I think this working group is the place to say, here's a recommended approach. It works. It's been tried on a very large network, and it's been thought out. So it's gone through the IETF process, been carefully thought out. So I think it's great. I have some minor comments on some of the stuff in the draft. I'll send that in email. But I think this is great.
You just want me to send RAs every few seconds, right?
Huh? No. It's about sort of, you say that there might be an inactivity timer, but I think you can use the neighbor discovery cache on the router, that sort of thing. It's sort of quite minor.
I'm just screwing with you, dude. I love you.
Uh-oh. No, there's no uh-oh. My name is Ole Tra. I wanted to talk about the MNO bits. No, that was a joke. It's a bit too early for the superlatives, but thanks a lot for writing this up. In 6man, we had this sort of work item that has been on and off for a while about under the umbrella of energy efficient ND, which never really has gotten any traction, but it has identified all these problems on ND has on large links and especially wireless ones. Some of those Lorenzo mentioned. Multicast doesn't really work. DAD fails in a high percentage of cases. If there actually was a duplicate, luckily there usually aren't. So thanks a lot for that, for this stuff, because it really does show you a deployment model where most of these problems just go away by definition, right? You essentially have a point-to-point link to each station. You don't need that. You don't need, well, you can do address resolution in one direction, but it still goes into that point-to-point link. So, I think this would be a very nice document to just point to and say, if you have these problems, go and look here.
Thank you. Fred?
Yeah, just one other point I forgot to mention before is that when you have A equals 1, L equals 0 in a PIO, that does not necessarily mean that prefix has been delegated to that node for its own exclusive use. So in an unmodified host, it's not possible to say that that's the same thing as a prefix delegation.
Okay.
Lorenzo Colletti, one thing I forgot to say, I think it would be nice to have more text in here saying, here are the advantages that you get. For example, some of the advantages that Ule mentioned, you get reduction in neighbor discovery traffic. To me, the killer advantage of this sort of thing is that you don't have to implement subscriber isolation because it's already done at layer 3, right? The thing that is really hard on these community Wi-Fi networks, I think, is always implementing the isolation. I think you should say clearly in the draft why it's so good to do it this way. And so these are the advantages. I don't think it does.
I'll tell you why. Actually, that's a very good point, because I don't have any data to support some of those statements, right? And I don't want to make it up, right? So one of the things that I sound Fred kind of on the side here is there's some assertions we can make, like that we know just from what the testing and the work that we've done so far. I think part of what the way I roll is I want to be able to say it is this benefit X is here because I have this data Y, right? I just didn't want to make crap up and then have people here throw stuff at me, right?
But you know, the thing about subscriber isolation, right? That's a statement maybe we can make already, because you don't have to do it at layer 2.5, you know?
Yep.
But anyway, yeah, maybe a consent.
Yeah,
text.
all that layer 2 stuff drives me crazy.
Stephen Bart, I think this is a very interesting draft, and I think it's very resourceful. And when I think about, or when I did community Wi-Fi in the past, one of the issues was always how do you deal with roaming? And I think this draft should have some statements on that, because that's usually when it comes to like Wi-Fi networks, and if you have a community network and there are multiple APs in range, you sometimes do get roaming, and there are sometimes issues to be considered. I mean, MPTCP and QUIC are not really rolled out yet. So if you get a new layer 3 address, it breaks existing connections. And I think this draft could benefit from some notes on that.
So Stephen, Fred and I maybe had an exchange on the mailing list about that. And we don't make a great deal of comments about roaming. And I took the item from the mailing list. I'll go back and I'll kind of comb through all the tasks that I agree to on the list. We have a limited roaming model, right? So the way all these APs, they aggregate on kind of this notion of an overlay network. And as long as you remain on the single aggregation point, right? So for example, Newcastle, Delaware would aggregate, Pennsylvania, New Jersey, and Delaware, right? So, if you're roaming within that range, then your mobility will stay intact, right? But if you go up to Boston, for example, you might have to renumber, right? That's not going to change.
No, I mean, that's fine. I mean, just simple grab for the word roaming in the draft, and I found nothing. So it's just like.
Understood. Yeah, well, that's on my list of things to do. Thank you.
So, thank you. So Lee and I have been chatting here. It seems like we've got two possible futures, and maybe both are appropriate. John, you described this as describing essentially your experiment, your trial deployment at Comcast, and plan to update it with further information as the trial progresses. We've had several calls, though, for some form of a working group draft that would actually describe what's a good way to do Wi-Fi networks. So let me ask, do folks want to invite this draft to be a working group draft? If yes, please hum. If no, please hum. Okay, I heard one there. Okay, John, would you be willing to take this and maybe take on a co-author, somebody that offers, and produce it as a guidance draft? Okay, let's plan on that then. What I'll do then is I'll approve a name for it, and you and I
attacks and so on. In most cases, I'd say that the security implications fall into one of these categories. Then we have some comments on the operational implications. The idea is that some middle boxes and intermediate systems need to obtain the layer 4 information when they are processing packets. And if for some reason they fail to obtain that information, in many cases, they just drop the packet, okay? Reasons for which they might want or they might need to obtain the layer 4 information is to enforce infrastructure ACLs, denial of service management and customer requests for filtering, or to do hash-based load sharing. This in particular could be improved. Actually, that's a change that we have pending for the next revision of the ID, because apparently support for the flow level has improved in apparently. So apparently has improved in host implementation. So eventually you could argue that this could be implemented in the intermediate systems so that they don't require to process the layer 4 information. And also there are packet forwarding engine constraints, which essentially means that, for example, you might have an intermediate device that can only look into a maximum number of bytes into the packet. So for example, if you have an extension header that is, let's say, 500 bytes long, well, that middle box cannot look that much into the packet, which means that it won't be able to find the layer 4 information. As a result, it will probably drop the packet. Another of the reason is for root processor protection. Essentially, when in many cases, when you have a packet with extension headers, a specific case is the hop-by-hop options extension header, on which there is ongoing work on 6-man about this. If the packet contains an extension header, it may be pointed to a software path, and obviously that has implications. So that's, for example, one of the reasons why the hop-by-hop options in particular is very largely dropped. And then finally, for example, there are cases in which an operator may want to filter, for example, packets that contain a routing header type 0, but the device can only filter based on the instance of a routing header, but not based on the routing header type. So essentially, the only two possible options is essentially to drop all packets that contain a routing header or allow all of them. So in many cases, they resort to dropping all of them. So this means that if those devices had the ability for like finer grain filtering, then in some cases, this situation could be improved. I don't know if there are any comments.
Jen Linkola. Quick comment on the previous document.
Yes.
I can remember if the document has been updated with mentioning that after 12 months approximately, we're still seeing the same results.
Didn't update. I redid the measurements and the results were essentially the same.
I think it's worth mentioning.
Okay.
And the document, like we done in 12 months, and unfortunately the situation is still the same.
Okay.
And on this document, it's a kind of gray area if I'm trying to filter in routing header 0 and incidentally dropping another routing header, can we say it's intentionally dropped? Or it's actually unintentionally dropped because I was trying to filter something else. So I don't know how it should be phrased in the document. Because, for example, again, hardware limitation when we don't have enough bytes on chip memory to look into packet. I don't think it's actually intentional filtering of the packet.
Intention, I would say in this case is given the options, it's intentional. It's not that you really mean to do that, but since you don't have, let's say, if your options are to allow all the routing headers or filter all of them, in many cases they resort to filter all of them. It's not that they really mean to filter all of them, but given those two options, that's what people resort to.
I just, to be honest, I just could not see the intent here.
Okay.
I'm just trying to, for example, permit TCP, and because of extension header, I filter the packet. I don't think it was my intent.
Okay.
So probably, I don't know, probably you should somehow reflect it in the document that a hardware limitation quite often leads to unintentional.
Okay.
Those packets being unintentionally dropped.
Okay.
Because my understanding, intentional filtering, if I'm saying I want to deny all packets with all extension header into my network.
So let's say that
it's my policy. If I just somehow trying to do something else and accidentally because of hardware limitation doing this, it's not my intent.
But let's say that you have a network and right now you are filtering extension headers because given the options you decided to. Would you flag that as intentional dropping or as unintentional?
If it's my intent, yes, but it's not. I'm not sure that all options all situations which are currently mentioned in the document are intentional, because I think some of them are obviously, I just did not think about it. I just filtering something else and I have to filter this. And the second comment, I'm not clear about the message. What's the recommendation? What we're going to do?
Well,
what do you recommend?
So right now we don't have much of like a explicit message. In some cases, like here, I mean, obviously the recommendation is that this should improve, right? For example, this case.
Oh, this is actually a very good point, because actually it was great discussion on Sunday on IPG. I don't have problem with those packets going to slow pass as soon as it's not compete with my BGP, ISIS and other control plane traffic, right? Let's say I have a small router and send all this traffic to very slow router. That's okay. So probably this actually might be addressed by the proper control plane policy. If I have some bandwidth allocated for this and send it to RP, and as soon as my router is still able to deal with control plane traffic and just allocate, I don't know, 100 megs for this traffic, that's okay. So I think this is not actually a problem as soon as our router vendors allow us to put this in the special queue and not overload my router and make it drop in BGP sessions.
Mm-hmm.
So probably would be worth mentioning this. So some control plane policy could help you with this particular problem.
I'm going to take Chair's prerogative to interrupt and say that to your second point, I guess, your first point on this draft, Mark Andrews said on the Jabber Room that we can describe that as collateral damage, where you have an intent and then you inadvertently filter more than you had expected to or had plans to, and that's probably worth discussion.
Hi, Bob Hinded. Yeah, I'm not quite sure what, as the previous speaker, what the point is. You paint this with a pretty broad brush. I mean, I sort of think about ESP as an extension header, and I don't think anyone's dropping that. But you talk about all the problems with extension headers and then that they're being dropped. So maybe that's not such a bad thing if they're so bad. So I'm not quite sure what the goal of this draft is and, you know, what new information there is here.
Regarding IPsec, I mean, while we didn't include it in this document, I did perform some rough measurements and they are dropped too. I mean, it's not that it's nice, but I've seen that.
So Warren Kamari, somewhat responding to Bob, I think that part of the purpose of this document is it's useful for people to understand that if they put packets with extension headers on the wire, there's a reasonable chance that they might get there. That seems obvious to many people, but it's not actually always true. Yeah, that might be, maybe the abstract or something should make that point stronger. And yeah, there are a lot of people who drop, you know, ESP because they're not expecting ESP. If you're sort of an end type system, you can be fairly sure what you're expecting and what you're not. So I mean, I don't think I'm likely to see an ESP packet or know what to do with it.
So they're dropping ESP because they're not expecting it. Would you describe that as intent or collateral damage?
I think that's intent, right? I've decided my web servers get 80 and 443. I know that they do not get ESP. I have sort of explicitly said the ones that I intend, and everything else I intend it to be dropped. So I think that's intent.
Following this comment, I think there are two different situations. First, when I have my system and I know what to expect, and I permit only what I shall expect and deny everything else, and it doesn't actually matter for outside world if I'm doing it on the intermediate walk, so it's a host firewall or whatever. And it's not And because we're actually numbering extension header from the same address space as protocols, for me, extension header is a kind of new protocol, right? I'm expecting TCP/80 and I'm permitting only TCP/80 and everything is dropped. It's policy. But if I am intermediate ISP and I'm suddenly start dropping this, it should be only if it's explicit security policy and my customer asked me, please permit only TCP/80 to my server and drop everything else. But if my customer would not ask me to do this and expect all traffic to be delivered, then filtering this stuff shouldn't happen. That's my opinion. We probably, again, I'm afraid that people might read this as a recommendation to filter.
It's not.
So are we stating it somewhere clearly? Or
I mean, it's not intended, probably it's not stated in the way that you mentioned, but it's just documenting why people do this without saying you should do it. You should do this.
Hi, Tom Herbert. So I had a question regarding the ECMP and the use of layer 4 information. There's also the alternative to use flow labels, and I believe we're pretty much at a state where most OSs are actually generating flow labels onto the internet. Would it be worthwhile to mention that in a document like
Yes, that's actually in the to-do list. It was mentioned by, I think, recall Brian Carpenter. And actually, one of the reasons for which it had not been included in the ID is that not a long time ago, the flow level wasn't properly used. So actually, recommending to use them or noting that it could be used for that, it was unrealistic.
Right.
But apparently the situation, I didn't measure that myself, so that's why I'm saying apparently that improved.
So it was a chicken and the egg problem. Now we have the chicken, we need the egg, which is the support and the hardware for it.
Sorry?
We need the support and hardware and the devices to actually support using the flow label for ECMP. And then once they have that, in theory, you should be able to switch packets without looking at anything beyond the IP header.
Yeah.
Okay, I can't tell whether this is something the working group wants to keep working on or not. It sounds like there's some discussion, but but people are still vague on what the intent of the document is, and I don't think we even can do a call for adoption until that much is clear. Warren, you're looking at me funny. Do you want to? Does anybody want to? Is this something that the working group wants to keep working on? Certainly, we can take it to the mailing list and keep doing that. We can take. You want to take a hum on? All right. So if this is something we should continue working on, please hum. If this is something that's not interesting to the working group, please hum. Okay. So we'll keep working on it, but not adopt yet.
Okay. Thank you.
Bob.
Yeah, Bob, one other thing. So in 6-man, we're doing the 2460. This is not a direct comment on your draft. We're doing the 2460 BIS update. And one of the areas that we're looking at is a little more guidance on extension headers. So it sort of relates to this discussion, but please take a look at that. There's a new section on new extension headers. There's, some recommendations for when they should be used, what the issues are.
Well, and one other thing, speaking as the author of an internet draft that Bob just mentioned, it might be interesting for you to look at that draft on hop-by-hop headers and comment on 6-man. So, okay, we have finished the morning agenda, and we've got, an hour left to go. So what I'm going to do is I'm going to pull the afternoon agenda forward. Phil? So.
Slides or is it
yeah, slide advance.
Okay, I'm Philip Matthews. This is the somewhat long-suffering design choices draft. Victor and I are really hoping to finish this draft off soon. So, just a quick reminder for those people who might have forgotten, the purpose of this draft is to describe basic IPv6 design choices. Lower level choices, then there have been a number of sort of how you deploy IPv6 in various situations, various environments. This one was supposed to handle sort of more low-level choices or more low-level decisions than you make in those drafts. And it assumes that people know something about IPv4. So we're now on the 09 version. And so what do we did? We made basically 4 basic changes here. So a summary, and then I'll go through each of them individually. So first of all, we added a paragraph to the introduction saying that the enterprise situation is in scope. This was something that there's been some discussion with over the past few months. We added a, well, it turned out to be somewhat controversial statement saying if you're using private allocated space internally, then an enterprise will have some difficulties in multi-homing and changing providers. And I'm proposing to change that text. We added a summary of results that we did a survey of operators over in sort of the early summer, and we added a summary of that to the document. And we added a paragraph. Some people had commented about ULAs and being different than RFC 1918. And we said, yeah, they're different, but operators tend to use them the same way. So,
question about what the same way means. Does that mean as a private address, or does that mean behind a net?
Why don't we get there? So I would just try to summarize, and then we're going to go through each of them individually, okay? Okay, so this one, I'm hoping this one was there. So way back 6 months ago, we said there was some people on the mailing list who said we'd like you to talk about some enterprise-related topics. EIGRP, for example, is one of the big things that people wanted. So we put that in. At Prague, there was a suggestion that no, really, enterprise stuff should not be in this document. You should pull it out and put it into a separate draft. We feel no, we're going to leave enterprise. Our proposal is to leave enterprise stuff in this draft. We're going to try to cover it to what we can. And, you know, our sense is if the working group really feels enterprise should come out of here, fine, we'll take it out, but we're not offering to do this second draft. So I guess I'm just wondering right now, does anybody disagree or are upset with our proposal? No. Don't see anybody running to the mic. So I think we have this question now finally solved, okay? Okay, let's skip this one. Okay, this is the topic I think might be a little bit controversial. So the question is, as an enterprise, what are your options for addressing your network internally, okay? So we added this sentence, maybe, let's see, is there a button that's a pointer? No, there isn't. You can read it up there, the second bullet. There was a lot of discussion about this on the mailing list. People were sort of upset. So what I'm proposing to do is add basically something that more or less says in some detail what I've put up here on the slide, that there are effectively 3 choices for an enterprise to use internally, okay? One, if you're a big boy, you can go and get PI space and use it internally. And in fact, that's what I suspect most IPv6 deployers today are doing. They go to IANA, get their PI space, and they go out there. And that has all sorts of good advantages. They can multi-home, they can change providers, all these nice things, okay? There are some disadvantages. You have to be able to get this space. I see the lines already started to draw it up. You have to be able to get this space. You must apply, of course, to whoever, your local RIR, and pay whatever fee they charge. And of course, you add the /48 to the default free table. Number 2 is you can get PA space with ULI space utility. That's nice, but it has a couple of issues. Today, I don't think that you can realistically multi-home. There is indeed work going on in HomeNet and elsewhere to try to improve the situation, but I don't believe, this is an operational working group. I don't believe that today you can deploy those solutions. And I'm happy to have people correct me and tell me that, oh no, there's a whole bunch of people that implement that. But my understanding is, as a document which we're trying to get out to give people guidance today, we can't say that that's workable, okay? And it also has the issue that, of course, if you embed those addresses in various places, it's therefore hard to change providers. So what we said is then there's option 3, which is the option that a lot of people don't like, which is you can use UL space internally and do NPT 6.6. And I know there's a lot of people there. And at that point in time, Lorenzo, take it away.
Yeah, so 2 comments, Lorenzo Colidi. One of them is that you missed the only solution that actually works, which is source desk-based routing.
So let me ask, do you know anybody? Is that actually can I actually go out and buy that today? I mean, yes, it's coming along, but I don't believe I can buy something today.
If you have urgency for this, you should beating down your vendor door to do that.
Okay, but
so my point is that I think the reason why the enterprise was the enterprise was a problem, I think, is this slide, right? So you can say in the slide before that we actually solved that issue, that we want to take on the enterprise problem, but then we'll disagree on how to do it. So yes, it would be nice to take on the enterprise problem. My personal opinion is that that problem is not actually solved because none of these solutions work. And so what I think—
None of them work. You don't even think, for example, number 1 works.
It doesn't work for everyone. No, it doesn't work for everyone, right? You can't go to say, you can't go to a small business and say
exactly,
yeah, right? So right. That one doesn't work. Number 2, you state that it doesn't work. I think number 2 is closest to working, actually, because if you avoid making the mistake in the middle box, then you're kind of fine, right? If you make the mistake in the middle box, multi-homing, that's not hard, right? You just change the addresses. Yes, there's some disruption. You do it at 3 a.m. on a Sunday, and it doesn't matter. Right.
Multi-homing. No, multi-homing is like, so I want to be able to have—
sorry. Yeah, I thought you said—
You're talking renumbering, yes.
Okay. Okay, so Jen had a comment. She'll repeat that later. Okay, fine. So that doesn't work either. Number 3 doesn't work because apps break. We have apps that will break, like video chat, right? And we should not be encouraging app breakage, right? And so basically the problem here is that we do not have a solution for this problem in certain types of deployments. Yes. And that is the reason why we're having so much trouble advancing past this point, because every time we hit this, we hit the snag, and we basically have an argument, right? So I think that was the reason why we decided not to go into this. And so I would instead, note that there is an important hole in our protocols here, and that we do need source desk routing to work, and that is the only way to do this properly.
So if I could summarize what you're saying, you think that an enterprise cannot deploy IPv6 today?
Anything that they do will have limitations, and so I would be hesitant to recommend, any of these. Except for number 1, which is maybe infeasible, right? So, but I don't know that we want to say, yeah, this is recommended, even though it will break a bunch of stuff, right? So, like particularly, for example, number 3.
So, the whole point of this design choices draft, the whole approach taking the design choices draft was to say, here are some options. Each option has pros and cons. Here are the pros and cons. That's what I'm proposing to do with this. Do you have a problem with saying that? Yes,
yes.
As an administrative enterprise, you can choose, this is what you get if you do this approach. This is what you have to worry about.
This is the problem that I have. Okay. The problem that I have is I think we should be working as a community to do something better than all of these. And I think that if we think that these are actually solutions, they're not. And if we start recommending them as solutions, we're going to settle for something that doesn't actually work well. And I think we should instead drive as fast as we can towards getting the real solution in place, because we are in the position of, I think, at least if your enterprises are like mine, we're in the position of having a large base of people who think in terms of IPv4. They don't understand any of these subtleties, and it is up to us to explain to them what the best thing to do is. And I think if we try to explain, if we say that one of these is the best solution, we are doing them a disservice. And I think instead we should be saying, look, this isn't solved yet. I have yet to see, sort of the middle tier of enterprises. Like the small tier of enterprises, it's basically residential. You can fix that with HomeNet. And that is happening, by the way. The big tier of enterprises, Google, Facebook, they use number one, perfectly fine. It's been working for years. So if you've got something that's like a mid-tier, I don't see those guys beating down the doors. Maybe you do, but they all seem to be like, IPv6, yeah, do we really need that still? So I think we still have a window of opportunity here to fix the protocol so that those guys can do the right thing without having to introduce app breakage. I don't want to be the one that says, yeah, let's go with number 3 and then break a bunch of apps and then have to push the cost on the app developers forever because it's not going to be taken out of the network. So I think we need to make a better choice here.
So Lorenzo, somewhere in the middle of that comment, you said that source destination routing actually has to work.
Actually, what's right? Actually,
source destination routing. I believe you said we need to make that work.
Absolutely, we must.
Okay, so question for you. In routing working group, in ISIS, in OSPF, there are proposals in that direction. You mentioned HomeNet. HomeNet has, the SATR work that they're doing. At this point, those documents in routing working group, ISIS, and OSPF have not been adopted, and there's been pushback. There's been questions about, so why is destination routing not good enough? Is it your opinion that this working group should send a note to the routing area director and the chairs of those working groups saying, please make it so?
Absolutely, and we should.
Okay. Now that's truth in advertising. I'm the author of all of those.
Yes.
But
so I think we will not get away from NAT 6.6 unless we fix that problem.
I hear you.
And
okay.
So I think we absolutely need to work on this. And my hope, which was misplaced, was I was hoping that we would try to fix this problem in the home because it was going to be easier. And everybody can laugh at me now. And it's, it took, I wrote this up in 2011. I was thinking of using ISIS. It was going to be awesome. And then here we are in 2015, and we finally extracted body part from body part. And we now have decided that we are going to do one routing protocol. So it was a mistake. I thought that we could do that. We couldn't. Well, it took us 4 years. And so perhaps we should have started running the enterprise side first, and you did do that. You wrote it up, and we had arguments there, and it never went anywhere. So yes, but I think absolutely we should do this, and we finally have conversion or working model in the home, and we should be scaling that up, and we should meet in the middle. Top end is going to do PI, mid end is going to be real ISAS using real Cisco, Juniper, real carrier grade, enterprise grade hardware doing source test, and then the low end is going to use whatever Babel. Well, actually no, not whatever. It's going to use Babel, and we don't have to do that anywhere. So that's what I think, and I absolutely think we should send that note.
Okay, so let me take a hum on that statement. If I'm going to send an email to someone and say my working group told me to send this, I think my working group should actually tell me to send it. So if you think I should send that email to the ISG and chairs of specific working groups, would you please hum? If you think that that's inappropriate, please hum. Okay.
Jenny Nicola, first of all, I wanted to second that Lorenzo comment. We definitely need another design option, because otherwise, if I'm an enterprise and I'm trying to deploy V6 today, I look in this document, and what are my choices, right? I don't even go to talk to my vendor because IETF is not recommending anything I want to talk to my vendor about, right? So I think we should discuss the proper design choices, even if not of them could be easily deployed. Because, for example, using PA inside, right? I actually some time ago did something like that for V4, And I managed to convince some ISPs to advertise other ISP address space as a whole. So they advertised other ISP prefixes allocated to me. So it actually might work for V6 as well, right? You just have to talk to a provider. There is no technical constraints. It might be a policy problem, but technically it could be done, right? And there are some other issues if you're using PA addresses from two ISPs, how you can make your device choosing the right address. Yeah.
Sorry, if I'm said you want to get PA space from one provider and give it to the other provider to advertise it for you.
Yeah, it's an option. I've seen it working.
Okay. Yes, I've heard it has there. Okay, that's a good point. We should probably add that one to this.
Yeah, and again, yeah, we definitely need to think about proper designs because everything here is just workarounds.
Right. So actually, there's an interesting question here. My opinion on this draft is that we should try to document sort of what people can do today. We should not be trying to document what people can do in, 5 years from now. Okay, that strikes me as the difference of this working group versus the other working groups in the IETF. Today, the ops working groups talk about what we do today. Other ones look at what we want to do 5 years down the road. And I'm looking a little bit at the chairs too. Is my view of that? Do you guys agree with that view?
Generally, yes. I think that I'm also looking around the room and seeing some other folks nodding, but I also look at you and say, that's such an operator kind of perspective, isn't it?
Well, yes, and I don't work for an operator. You do, so maybe I'll.
And it turns out this is V6 ops, so that's probably appropriate.
Right. So that's why I tried to put the works under number 2, saying, it's difficult today. It may get better as things improve, as we get source-based routing going, but today we don't have that.
Which, by the way, is not to say that we can't include considerations and mentions of future work and
absolutely
watch this space for better solutions in the future.
Right. But so my goal with this draft is to try to say, what can people do today? Okay. And then, say things may improve, but let's focus on today. Okay, go ahead.
David Lampotter. So this slide and the sectional draft looks at what addresses are being deployed for an enterprise. And I think this is missing a different question, which is how those addresses are being deployed. What I want to look at is, I would assume that 99% of enterprises deploy those pick a prefix and deploy that statically, but it's perfectly viable to have some kind of automated system that you pop in the prefix once and it configures your DNS, DHCP routers, whatever. And there could be some dynamic system that an operator has deployed currently without some proper protocol for that or anything. And I believe finding out if anyone is doing that or if putting a few words on that is useful.
So you're saying a system where you can sort of dynamically add addresses out to all your DHCP servers, your et cetera. Is that what you're asking?
Yeah.
I know that there is a bunch of work that's going on. Operators are trying various things where to sort of do more automatic deployment of configuration. So yes, that there are people who are playing with that, some people who are doing that type of stuff today. I'm not sure in terms of DHCP servers, but certainly in terms of other configuration.
Okay, that should be in the draft, in my opinion.
Okay, fine.
Dave Taylor, just wanted to support your position of documenting what can and cannot be done today and keeping the enterprise stuff in this document. I think it is probably good to not make a recommendation, right?
No.
Unless you're a big guy, in which case maybe you can recommend number 1 or something.
No, I don't think.
But if you're a small guy, right? I look at this as being, this is an opportunity to say, here's the problem statement. All you have is bad choices if you're a small guy. Here's the problems you're going to run into, and this is why the other group, 6-man, et cetera, should work on other stuff. But what you can do today is you have bad choice number 1 because you're a small guy, right? If you're a big guy, choice number 1 is not a bad thing, or bad choice number 2 and bad choice number 3, and here's the problems you're going to have. And documenting that is a good thing because otherwise they'll do it without knowing what those bad things are.
Yeah. So, I mean, this draft has always taken the approach of not, unless there's strong sense in the working group, is to just say, here are the pros and here are the cons. Now, operator can make an intelligent choice about which way you want to go.
Hi, my name is James Whitya at Nest Labs, and I don't like choice number 3 because
You're not the only one who doesn't like it.
I personally think that there are no circumstances under which choice number 3 is better than choice number 2. And I'd like to comment about that to explain why. One, it seems to me that the easy to change providers, the difficulty if PA addresses get hard-coded, you have the same difficulty in choice 3 as you do in choice 2. There's no difference.
Why do you say that?
Because you have provider aggregated addresses in choice 3. If those get hard-coded into any system, then when you change providers, you have the same problem of getting those hard-coded addresses changed.
But presumably in 3, you just have to change a very small number of devices in your DMZ.
Where are you using them in any other case, right?
If you're using, so number 2 says you take PA space and you deploy them, throughout your enterprise internally. All desktops, etc., get PA space. Okay.
And they also get configured with information that knows about potentially. I mean, all the interior hosts might get configured with information that knows about provider aggregated addresses that are in your DMZ. You change those DMZ addresses, and now everything that knows all that configuration on the interior hosts, they all need to be changed. You have the same difficulty. It doesn't
under 3?
change. Yes.
Under 3, no, you use only ULA space internally.
Except for the things that are in the DMZ that need to be renumbered when you change your providers.
Right, but presumably that, I mean, the simplest case, that is simply the NPT66 box. That's the only thing.
It's the same difficulty when you change providers. I also would contend that the thing about multi-homing is that it's actually not really difficult to do the fairly simple thing of multi-homing where I'm changing my provider. So I have 2 homes and one of them is still in use because I've got hosts that haven't stopped using it. And the other one has just come online and I've got hosts that have started using it, and I'm shutting down one as I bring another one up, the graceful move. And it seems to me that that's somewhat difficult if you're a small enterprise, but it's doable. What's really difficult is having 2 homes at the same time that you are actually routing.
Yes, that's what I meant by multi-home.
And if you really, really need that, maybe you need to be bigger. But okay, I get that this is a thing that you would like to do. I'm not sure it's any
easier. If HomeNet is
to...
looking at multi-homing for individual homes, I think this would be something that an enterprise should reasonably do as well.
But I don't think it gets any better when you add an NPT66 box, because you still have multiple provider aggregated addresses that are potentially mapped to things that you have in your enterprise, right?
Sorry, I'm not following that.
You have 2 public addresses if you have 2 homes. Yes. The NPT box is hiding that fact at the cost of application transparency violations, but you still have the 2 addresses. So you can use one or the other, or potentially both of them at the same time. You're relying on that NPT66 box to do it for you. But anybody who's communicating with you has still got to deal with the fact that you have 2 addresses for each home.
Yes, that's correct.
That doesn't strike me as being easy.
Okay, it may not be. I guess the answer, what you're trying to say is none of these solutions are perfect. I think more or less you're saying the same thing as Jen was. None of these solutions, they all have pros and cons.
So to conclude, I would like to point that last line in the last column on the one that you list as a pro that it is similar to IPv4, and I would suggest to you that that's not a pro, that's a con.
Okay, I meant that only in that most IT people are familiar with the solution today. Okay.
Hi, Igor Goshinsky with Yahoo. I kind of have an issue with documenting what we have today in an RFC and then not saying that this is bad. Because the problem is you document it today and then some enterprise goes and says, hey, I need to do this whole V6 thing that I don't know about. Somebody's going to go, well, here's an RFC for what you can do. And guess what? People who are not familiar with V6 aren't going to understand this unless you put it in really big, clear letters. Bad idea and bad idea. And frankly, 2 and 3 are horrible ideas. Like they're a terrible thing to do.
So you think that everybody should do 1? Is that what you're saying?
I think I think everybody should either do 1 or wait till there is a better solution. Or frankly, 1 is not Yeah, one works fine actually too. 2 works fine without ULA. Yeah, 2 works fine without ULA, but the second you add ULA in there, shit gets murky really quickly. Because, you know, it's easy to talk about DMZ until you start building an actual network. What the hell is a DMZ? Everybody talks to everybody. Everything is a DMZ. Therefore, everything needs an address. And at that point, everything is just PA, and okay, your choice is PI or PA. Either way, it's real addressing. Really, it's the same thing. And that's, I guess, what I'm trying to say is that 2 and 3 should be spelled out as bad design patterns.
Okay.
Jelenko. Yeah, I agree that the problem is when we publish this as an RFC, people will be reading it for a long time, and by that time we probably might have solution number 4, which is not on this table working.
Right.
So we definitely should make some recommendation. We should say this might work now, but it's not a good idea. This number 4 might not work so easily, or you need some tips and tricks and dirty hacks on your equipment, and some scripting maybe even to make it work, but it's what we should be doing theoretically. And by the way, number 1 might also have number 1.1 saying, get your PA space. Go
Sure.
to RIR and ask for PA space and get multi-home.
Okay.
Some enterprises, not small and medium business.
Why would somebody who can do 1 want to get PA space?
Oh, I actually seen a lot of people doing this because you have to pay anyway. You get BGP anyway, so why not to go to RIR and get PA space then?
Right. So, sorry, I thought you said with somebody who had number 1 would get PA space.
Yeah, instead of PI, you can get PA. There will be no cons adding /48 to default free table because you get proper PA block in this case.
Right. Right. But
Yeah.
how is that? I don't understand. I think you're mixing 1 and 2.
No, I'm mixing. I'm understanding number 2 means you get PA from your ISP address block. You get allocation, assignment, from your PA address block.
Right.
Number 1 might be you go to RIR,
yes,
get your own PA, and you
Yes.
get multi-homed, and everything is
Yes.
everyone is happy.
Yes.
No, you're not populating default free table with
Right.
/48.
Right.
So we probably need to clarify this.
No, you are getting into the default free table. If you get your own block, then you do
Yeah,
have
but
to
it's
be
not going to be /48, which theoretically people might not be happy. You get
have
like
your own
slash.
block, isn't that PI?
Yes.
That
PA.
really sounds like
No,
PI.
okay, there is a difference between PI and PA, right?
Yeah,
So
you
probably
get
if you
PA
just
from your
confuse
provider.
those things in one table,
Right.
it needs to be clarified. PI means you go to RIR and say, I want to get provider independent block, or you get provider aggregatable block for your own.
Right. So
you said LIR for PA space.
Yeah, you get LIR, yes. You go to RIR
heard
and
you
then,
say
I want to
RIR.
become an LIR.
I thought you said RIR for PA space, and I was confused.
Ah,
You said
sorry.
LIR. That makes more sense.
Hold on, Joel Yeagley here. I think what you're doing with it is a distinction between policy in various regions and what you call people who get assignments, right? In the RIPE region, they are called LIRs, right? And
Yeah,
they
okay.
assign addresses to things that are called customers. And like the debate over whether you have PA or PI is really about attachment costs, right? When I run an ice cream shop, I want to have really low attachment costs to my provider, because like my provider, like my CPE is my phone or whatever, right? Okay. If I'm a colo facility, I probably have much higher attachment costs because, well, there's a wire running into the building, right? And that the same thing applies to your relationship to RIRs. Most people have very low attachment costs to RIRs because they just get addresses from their provider. Some people have higher attachment costs to RIRs because they receive addresses from somewhere else. Like, those are all like very qualitative distinctions that are made by people making purchasing decisions. They don't really they don't really arrive at sort of the technical level until after they've dealt with the economic one, right?
Okay, but my point was just we might discuss both options of getting your own address space because in some cases it might be 2 different options.
Okay.
Eric Klein. Let's see, insert generic repeated ULA rant here. And then I also wanted to make an observation. The routers that run the internet today, I think, are not the same routers that run the internet 10 years ago, if only because of the 512K problem, right? And so for the con in 1, adding a /48 to the default free table, I just wanted to observe that if we move the DFZ boundary from /32 to something larger, that pretty much everybody could get, and eliminated the difference between PI and PA. Yes, router memory, router memory, router memory. But thinking long term, I wonder whether or not we should think about moving /32 a little closer to 48. It is already 48. There are, yes, plenty of 48s in the DFZ. So you're saying, are you telling me that that con is not actually a con?
No, what I was just saying is that if we seriously mean we want every enterprise to have their own provider independent space, like no enterprise should go to their upstream to get address space. They should all directly go to their local RIR and get address space. Then our routing tables are going to get much larger. Right?
Which may not be a problem.
Yeah, right. Hold on. I think we can probably discard that, like that problem with respect to this debate, because it will not be solved like tomorrow. Like we could actually have that debate for months or years because we've actually had it for decades already. And I think we actually need to solve it here. Like okay, as your AD, I don't want to hear it. Like,
If I may only make a clarification, it is an option, if we choose to make a recommendation, to say use number 1 until source desk routing is ready, which will be a couple of years.
Yeah, sure. I mean, using PI space is always an option.
Yes. Actually, Lorenzo, I would almost comment that in practice, that's what people are doing today.
Yeah, I mean,
nobody particularly likes 2 or 3, and so everybody who is deploying IPv6 today, I think, is doing 1.
Today, there's like 56,000 ASNs in the v4 internet, and there's 10,000 in the v6 internet, right? Okay, that's not very many entities, given that there are 7 billion people on the planet. Like, we don't have to solve this.
Yeah, and I had a couple of comments there. When everything that's been said about PI is true, and it's, Christian Uitema from Microsoft. The point I was making about the deployment scenarios and multi-homing is that there are actually 2 multi-homing scenarios, load sharing and backup. And that they ought to be analyzed separately.
Good point.
Because, I mean, they have different things. And in particular, your solution number 2 might not support load sharing without source destination routing, but you can absolutely support backup. I mean, with a modest interruption, and you backup. And for an enterprise, there's a world of difference between being cut for 5 days and being cut for 5 minutes the time that you bring your backup back in.
Okay.
Now,
good point. Thanks.
The other point is that practically what you have heard there is that solution number 3 is inferior in pretty much every dimension to solution number 2 and 1. And the draft should very much make that very apparent, so that precisely we don't have the side effect that, oh, the IETF has written that it is a plausible solution, hence I do it, because otherwise some guy are going to sell it. So the draft should be either very clear to basically completely discourage option number 3. It has no benefit compared to any of the other ones. The point about multi-homing was very clear. I mean, I expect that people have internalized that your external address is as much part of your configuration as your internal address. If you change it, you have to change it to all your peers and all that. And the fact that you change that with a NAT or with a reconfiguration doesn't make any difference.
Okay.
Lorenzo Colidi, I just wanted to echo Igor's point. If we do, and like my preference would be to strike 3 from the record entirely, take it out of the document and say this is a bad idea and we shouldn't recommend it. I don't know if everyone's done this. MPT66 is experimental. Insert generic URA rant here. Like there are a lot of people that I'm sure aren't very happy with number 3, as we've heard. My preference would be to strike it out if we want to say anything. That said,
So I would actually argue not to strike it out because it is aware there. And I mean, the whole point of this document is to describe what the alternatives are and give the pros and cons.
Then list alternatives 1 and 2 and say that there's bad alternative number 1, which we do not recommend. I would support that.
Why not number 3 considered harmful as a second?
I'm perfectly fine with that. If we put, Okay, if it's number 3 is listed only as an example of what you shouldn't do, maybe that's fine. I don't know. It's you know, we just listed the cons and say don't do this. Is that okay with the authors? Are you willing to say this is a really bad idea and people have been doing it and they shouldn't?
I'm not sure. I think there are a lot of people who are looking at doing this. I think the whole point of this draft, as I said, is to list what we consider the options and what we see as the pros and cons. And we can certainly talk about what we want to say as the pros and what we want to say as the cons. I'm definitely taking the point that a lot of people don't like 3. So we obviously should try to work on the appropriate wording for 3. I personally don't think we should take it out though, because it is out there. I think there are people doing it and it should be listed. Otherwise people say, well, what about this option that's not listed in your document?
I'm fine listing it as a non-option to avoid personally, right? If we say, here are the 2 options, we realize that none of them are good, and then people, we've heard that some people are doing, I don't know if we have, I don't think anyone actually uses NPT66. What I think that they use is ULA plus NAT66, which is not even something that we're willing to write down, okay? But that is the truth here, okay? So I have a problem with publishing a document that skirts the truth in this way, but okay.
I have spoken with 3 companies in the last 2 months about NPT66, and yes, we're guiding them away from NAT66, but there is serious interest in NPT6.
But that was what they were using before, yeah? NAT66? Or they weren't using anything?
Well, they're using NAT44.
Okay.
See, this is the point. I think there are enterprises that are doing these things. There are enterprises that are looking at 3. So that's why I don't think we should take it out.
Well, then we should say that this is a bad idea for the long-term outcome, because it is our role to do that. It is our role to provide guidance to the operational community and to the people making protocol designs to the effect that this is a bad idea. If we want to say, if we want to say that this is, just bad, then okay, let's do that. Okay, Igor.
But I will point out that there are if I can sort of argue for 3 there are a lot of applications today that know how to do IPv4 NAT traversal. Okay, it's become a big thing today.
Do we want to keep paying that cost forever? No, we don't.
So
when we ported the V4, we ported the.
We all want to say the same thing.
Yeah, no, when we ported the libjingle code to V6, we left out the NAT traversal part.
Okay.
Okay, it will break.
But you have to do a bunch of that anyway to get through the firewalls.
Oh, no, because your address is the same. If you don't translate the addresses traversing the firewall.
But you still have to deal with the fact that you have
to rendezvous.
Have to start.
All you need to do is send the same packet in both directions. Right. The first one gets blocked and the second one gets through. It is much simpler. Okay. As an application developer who reviewed that code, it was much simpler. Okay. And we will, we don't want to get stuck in that again. As James said, that's a con. Okay.
Michael Abramson. So I would like the recommendation to be use GUA addresses, use PI if it's hard for you to renumber and the attachment cost, you're willing to take that. Otherwise, get PA, and yes, you have to renumber when you change ISPs. So yeah, I just think we should try to steer people away from ULA and the NPT66.
So I think George Michael's and Napening. I think Christian's comment about the difference between why you are in a multi-homing world is very important and should be borne in mind, because there are needs in multi-homing that have no address consequence if you were only aiming to achieve resiliency and single point failure removal. I think option 3 is not a good idea, and there are implications in constructing a table of choices in some neutral language, which somehow implies that there's judgment-free qualities here. We're making an explicit judgment. The current opinion, and I would say it's an emerging consensus in the room, is it's really not a good choice. So putting it neutrally in a table of, oh, you could do this, removes all of that quality. I think you have to go further in saying, please don't do this. That's what people are saying. Please don't do this choice. That whole issue around vertical capture of information and addresses passing through CGN and NAT devices and 3-point rendezvous to work out your external address, we're trying to get away from that. And if you include this class of technology, we go straight back into that space, which is why the first two are so much more important. And lastly, I think Yoel's observation about the economics of where you are and what you're deploying happen before you hit the technology, I think that's very true. And that applies reflexively back in routing. We're making assumptions because of mental models about stresses in routing and problems in routing that probably aren't appropriate. And I think there's a quality of a false dichotomy or a false trichotomy here. When Lorenzo got up and said, but we could fix this problem using source-based information in the routing decision, that's immediately another choice that has to be understood will emerge in the fullness of time. So I wouldn't construct a model that says these are the three prescriptive states, because it neutralizes a real technical opinion, don't do one, and it excludes future possibilities.
Okay, so if we just said that these are the three choices that you can do today, and here are the current views of the pros and cons, and that there may be future approaches. How does that? Okay, sounds like you're happy with that one.
That's George. I think we seem to be arguing about something that is not actually related to this draft. And so we might be able to unstick this one by addressing the more fundamental problem, which is that it seems like an awful lot of people regard the existence of NPT 6.6 or NAT 6.6 in any form as fundamentally a bad idea that made a lot of people unhappy. So the solution to that is gain consensus and declare that historic, correct the mistake. If that's actually what the issue is, write a document that says this is worst common practice, do not do this ever, considered harmful, whatever the strongest language it is you want to use, and then mark the draft historic. So, or mark the RC historic so that this is no longer a point of discussion. This is no longer if we truly believe that there is never ever a valid use case for this that cannot be done in a different way, then we should have just turned it off.
Wes, are you volunteering to author that draft?
No.
Shimiaka from NTT Communications. Then, sorry about that, and I didn't join that discussion for long, but reading this and also hearing about that, and so people, then my question, my option, opinion is actually some people already pointed out, those are not the fully available options. There are several numbers of the different options still, including NAPT66 even. I mean that NPT66 is slightly, good comparing to the NAPT66. But unfortunately, we already observed that there are a bunch of implementations in market, especially for example, Oracle OpenVM already implemented an NAPT66. I heard about that recently. VMware Workstation newest version say that we have IP version 6 option. I checked it out. I heard about that. That is NAPT66. Even IETF people doesn't like those kind of things, but there are a bunch of implementations. So how we should do? Should we go to those companies to say don't do that? That works. I'm just curious about that. Then, as IETF, maybe there are several numbers of options. Let's have a complaining about that. Don't do that. That works again. So I'm just curious about that. If you have very opinion neutral comparison, you should have even some situation we do not want to do that. So in addition to those very bad ideas should be listed on it. And also there are a bunch of the solutions in addition to that. So, that's my, opinion and also the comments on, to that draft.
Okay, that's a good comment. And I must admit, just going back to Wes's point here, I'm a little bit worried that the IETF is going to get back into the situation it got with NAT 4.4, where basically nobody in the IETF wanted to talk about it, so it was going off in the industry, everybody developed it, while the IETF ignored it for roughly 10 years. Okay.
In that case, we should be careful about that, the difference between NPT66 and also the very pure NAT 44. And also the NAPT66 and NAPT44, right? That's different technology. So don't be confused, please.
Okay.
Lorenzo, quickly, 2 quick points. Number one, so NAT44 had a very strong commercial motivation behind it, which is that ISPs wanted to extract more revenue from residential users by charging them twice. That battle was lost, and I think we know what happened there, and I think we can avoid it this time because ISPs are now providing 56s to their users. Okay, so that was a very important motivation to NAT44, perhaps the most important, and that is no longer here. So another thing that I said is, I think you just said a little bit earlier that you're okay with listing 3 in a table. I think there seem to be a number of people that would be unhappy with that. I just wanted to make sure if that was what you said or it's not what you said.
I don't know. I'm going to have to go to figure out how to present all this. Most likely, we present it the way we do the other choices in the draft today, not just sort of give it as here are a bunch of options and here are the pros and cons.
And I think you will find a battle on your hands if you do that. That's just what I'm saying, because the people that have lined up to this mic saying that 3 is bad and should be listed as a non-option or instead something to discourage. I think it's reasonable to assume that those will show up on the mailing list and start saying the same thing. So I would not, in the interest of time, if you want to get this through quickly, I would not recommend taking that path immediately. I would try to think, well, what would make those people more willing to sort of have consensus on whatever it is you want to write.
Okay. So I'm sorry, I'm going to interject because I want to make sure we have clear guidance for the authors. So the idea is, are we saying that they should not mention it? That they should mention it in a special addendum that says, do not do this, or they should mention it among the rest of the options and say, this is the worst possible option? It sounds to me like number 3 solves is the consensus position to say, list it and say, list it among the possible options, but say, and here are all the reasons this is not the option you want to choose.
I heard a lot of support for do not do this ever, and here's why, but that might just be me. I'm biased. But I think, yeah, so I don't know. Because the point here is to say, here's what your options are today, and when you make that statement, you should say, here's what if we believe that we have consensus on this, it is appropriate in this document to say, here's what some people are doing, and that's a bad idea for these reasons. It's fully appropriate for this document. If that's the statement we want to make.
So I think if we do that, we should address the issues that are being raised by those that are headed off in that direction, which have to do with route symmetry and what's the other one? Route symmetry is a big one. Well, okay. Oh, and the other one is the complexity being moved into the enterprise network in terms of having multiple prefixes in parallel. I find myself wanting to go back to some customers and say, would you be willing to make a presentation? I think they would look at your comment that we think it's a bad idea and say it might very well be, but you haven't responded to the concerns that have been raised.
Right.
Dave Taylor. So I think out of your 3 options, Lee, I think not number 1, which was remove it, right? I think keeping it
or point in time statements or destinations?
Actually, that's an interesting point. All we did right now in the document is say, these are ones that people have run. We have a spreadsheet of data which we haven't published because, you know, it actually contains names and things like this when we didn't feel we should put it out there. We could try to put this there. If you think that would be interesting, we could try to, you know, one of the questions I do have, you know, for discussion is whether we should try to boil or put a little bit more information out there. Do you think that would be interesting to say?
I think it would, because eventually I think I'm going to bet that those three who are up top there, they're probably going towards the one with 12, for example, right? Yeah, at least some of the three. I mean, I think it's just an interesting data point because it helps people understand what the trend is, where the direction is going, and ultimately it depends on what the purpose of the data is, right? If you're just trying to give people guidance as what they should be looking at and where the development's going and the maturity, that'll help, right?
The original point was simply to give people guidance if they were trying to choose it, whether other people had chosen that and had good experience with it or not. But I think also directions and trends could be interesting. So, okay, good point. I'll take that. There. Any other comments on this? No. Finally, okay, there was a comment. So in the draft, we tried to talk about dual stack networks, you know, running V4 and V6, and we used the term private to talk about, you know, to mean either a 1918 address or a ULA address. A number of people commented, well, there's really a bit of difference between 1918 address and a ULA address. The point where the position that we're taking right now is, yes, there are technical differences between them, but operationally, operators use them in the same way. And I can see that Lorenzo disagrees with that
question that I asked earlier. What do you mean by in the same way?
Okay, maybe actually, Victor, do you want to go off and take something on that one since you're the very strong supporter in that?
So, we'll comment. Well, the selection criteria and where you'd use them on the network and what devices you apply those addresses to, when I was doing the operator side of the house, was this a very similar selection criteria. So that's kind of what we meant by private. And so, example. I probably shouldn't give the exact, I guess it could, like places like modem addressing in a cable network. You could use, you know, ULA space is a very viable address space, you know, based on the scope of it. Not intended to have internet access. And, you know, the previous version of addresses there would have been an RFC 1918 address space. In this case, you would choose a ULA space. There's other scenarios we can go into it on the mailing list if you want, but that's what was the point of it.
Well, the point behind my question is that RFC 1918 almost invariably implies NAT, where a EULA space is simply an address space. And if you're talking among consenting adults or within a domain, it's an end-to-end address. So it doesn't necessarily imply NAT. And so I'm trying to figure out what this has to do with translation.
I think the use case that Victor just gave of devices that don't have internet access does not imply NAT. Cable modems, when you put them in RFC 1918 space, there's no NAT because it's just privately addressed. So you can use ULA for that too.
So to me, they're different. They're not the same way.
No, the addresses are different, but where you apply them to the network. So many places we used RFC 19 address, ULA for a lot of those use cases was the comparable thing you'd want to use in IPv6.
Yeah, but it's a different Venn diagram.
When there's no NAT, yes.
It's not comparable because one of them is logically a superset that encompasses different behaviors to the other. 1918 is a constrained address space that has no uniqueness property. ULAs are probabilistically unique and have properties that you will not get if you deploy 1918. They behave differently. Secondly, people construct network spaces like Apple's use of ULA for Back to My Mac, or the supposed gaming network that's been constructed by a large West Coast American agency. It's nothing like a network you would construct with 1918. So they don't behave the same. They're not called the same. They're not the same. I don't think you should refer to them in the same bucket.
So I'm sorry, wait, Victor, hang on. I'm sorry, we're actually out of time. And we're gonna have to pick this up this afternoon because we're already over our schedule. And I'm sorry, Phil, for making you come back this afternoon.
This is embarrassing
It is a clear violation of 4193. We cannot publish this.
Lorenzo, the mic is closed. We'll
Okay.
talk to you this afternoon.
Currently working on, our connected home stuff. Like smart plug, bunch of sensors, things like that.
Yeah, the whole room is. Yeah, there's a lot of that. Are you doing like IoT stuff?